Hello, and welcome to another lesson on functions. Some of us might remember that in one of our previous lessons we covered plugging a function into another function. Here, today, we'll learn how to deal with variable function equations and some odd-shaped graphing problems. Why don't we get started? In this following equation, P of x represents the profit of x units of items that is equal to 17x minus 10x plus b. We know that b is a constant and that 300 units can generate a profit of $1,900. Knowing this, we're asked to figure out what b is. The first thing I would do in a question like this would be to plug in all the information I know. So replacing P of x is equal to 17x minus 10x plus b, we have $1,900 is equal to 17 times 300 minus 10 times 300 plus b. And we get 1,900 is equal to 5,100 minus 3,000 plus b. Now 5,100 minus what gets me 1,900? Well, let's subtract here and we get 3,200. Therefore, 3,000 must be added to 200, or the value of b. Choice E as our answer. Now let's move on to another slightly harder problem. Here, we can see that the ACT is replacing f of x with f of a. It's the same thing, but masked using different variables here. So we can set this equation the same thing as f of a is equal to the absolute value of 3a minus 17. Now, what's one possible value that will make f of a less than a true? Well, the first thing we have to do is try to put a series of possible variations. I would start with a 5 first, since it seems to be very close to setting this overall equation closer to a 17. So we have absolute value of 3 times 5, or 15, minus 17. Since we have negative 2, we have the absolute value of 2. So is 2 less than 5? Yes. Let's move on now to another function equation that is slightly harder. A 100-day period that captures b activity is written as follows. If k is a constant and n of t represents the number of b's in the range of 0 less than or equal to t less than or equal to 99, what's another day that's going to be equal to the amount of b's there were on day 10? A very simple problem that can be solved by first plugging in our variables. So we have n of 10 is equal to 10 squared divided by 2 minus 20 times 10 plus k, or 100 divided by 2 minus 200 plus k. Once we simplify again, we have n of 10 is equal to negative 150 plus k. Since we now know that on day 10 we have an equation that is equal to negative 150 plus k, we can set our original equation equal to the value it is on day 10. So we have n of t is equal to t squared divided by 2 minus 20t plus k is equal to negative 150 plus k. And we're left with t squared divided by 2 minus 20t plus 150 is equal to 0. To get rid of the denominator in the first term, we multiply every term by 2, and we have t squared minus 40t plus 300 is equal to 0. Therefore, t minus 30 times t minus 10 is equal to 0, or t is equal to 10 or 30. Now we can also plug back in to test our answer as a double check. So we have 30 squared divided by 2 minus 20 times 30 plus k, giving us 450 minus 600 plus k, which works out. So in summary, always remember that f of anything is the same thing as f of x, and to always plug in our variables and then solve for one another.